First problem, I'm going to go over 5A. So first problem, what I did, I gave you a box, 6 kilogram, right? And there is someone on the rooftop and pulling the box, right, using the rope. All right, using the rope, of course. And the box is moving up with constant velocity, right? Constant velocity 1 meter per second. What does that mean? This means constant velocity. The arrows are same in size. So constant velocity, right? Okay. So the tension, we want to know, we want to find the tension force, right? Okay. So someone is pulling. So what is the gravitational force acting on this body? Okay. So this arrow has to be same in magnitude as this arrow. It has to be a little bit bigger because, hey, the constant velocity means F net is 0, meaning acceleration is 0. So this is your Fg, right? So there are two forces acting on this. They cancel each other. Therefore, the net force is 0, acceleration is 0. So what are you going to do? You're going to study your conversation with Newton. Second law, as always. Don't forget to put an arrow because it's a vector quantity. Arrow is a vector quantity. Mass is a scalar quantity. Acceleration is 0 for the reason we explained over here. All the forces acting in the y direction. Ft is positive minus Fg is negative is equal to 0, right? So Ft is equal to Fg. Fg, we know that because I gave you the mass of the box, 6 kilogram, and I asked you to use 10 meter per second acceleration due to gravity. So tension force acting on the rope is 60 Newton, right? So this was the problem number 1. Now we're going to do problem 2. Problem 2, similar to problem 1, you have a 50 Newton box. You're going to do it two different ways, right? And then you are on the rooftop and pulling the box, of course, and there is a force downward, of course. Okay, so 50 Newton object, and you there is an acceleration, of course. Acceleration is 10 meter per second squared. All right, so Ft, I want you to find Ft. Okay, so what is the tension force acting on the rope when you move it up, standing up on the rooftop, moving up this box toward the rooftop? Okay, so this is what I want you to find. Now we're going to use two ways to solve this one. One is the regular way, and that is writing F equal ma, right? And all the F at the y direction, nothing going on at the x direction. So you have Ft minus you have Fg, and you have Fg is probably you're thinking, what is Fg? Fg is 50 Newton is equal to m is ma. So ma is directly of course you have mass. Mass is, let's find out the mass. So mass is F over so F equal to ma. So mass is F over a, right? In this case, F over g, right? M is, F is of course 50, g is acceleration due to gravity, so mass is 5 kilogram. So you put 5 and you put acceleration. This is not acceleration due to gravity. This is the accelerating, the object is accelerating upward, the net acceleration. Okay, so 50. Okay, so Ft and what is Fg? Fg is 50 Newton, so minus 50 is equal to 50. So Ft is 100 Newton. Okay, let's solve this problem a little different way. Okay, so 50 this 50 Newton I want to find the mass. So 50 Newton, okay, 50 Newton. I want to find the mass. So what is mass? Mass is, of course, always, without any exception, Fg over G, right? Always, without any exception. So mass is why? Because the gravity is the gravity is the force acting on the mass. So the mass is 50 Newton, and on the Earth you have to divide by 10 meter per second squared. On the Moon you're going to have to divide by 1.6, right? Yeah. So mass is 5 kilograms. So you're going to put 5 kilogram over here. Now you can solve this problem in a traditional way. So this is your Ft, this is your Fg, and there is why this is bigger, because there is a net acceleration upward 10 meter per second squared. So again, F is equal to ma, all the forces, what are they? Ft minus Fg is equal to m is 5, a is 10. All right, so Ft, Fg is, of course, we're gonna find mg, m is 5, g is 10. All right, so 50. So minus 50 is equal to 50. So Ft is 100 Newton. So that's problem number 2. Yeah.
Oh, yeah.
What happened?
Oh no, just wanted to tell you the plan.
What plan, baby?
So right now I'm gonna do E&M,
Huh.
and then I'll do thermodynamics, and then when I get tired I'm gonna take the physics GRE.
Physics GRE. You have to prepare for physics GRE. Make sure you take the physics GRE subject test today.
Yeah.
Okay. Practice test. Okay, baby.
So
good luck.
In the meantime, I'm studying E&M upstairs, and then I'll
Okay.
come in the basement.
All right. Keep me updated. Okay.
Can I go in the
Yeah. You can go. You want to study with your brother?
No, I
Okay.
just want to study alone.
Okay. So problem number 3. Problem number 3. I gave you a diagram, a velocity versus time diagram. So what did I give you? I gave you probably velocity versus time diagram. So I gave you like this, and then this, and then this. Okay, and then I also give you more information. I give you time. So this one is 1, this one is 2, this one is 3. I'm not drawing it to the scale, and I'm not trying to drawing it to the scale. This one is 4, this one is 5, and this one is 6. All right, more or less. Okay, so this one is 1, and this one is -1. Okay, so this is what you have now. What we want to do is I want to find the displacement, total displacement. To find the total displacement, here, so I'm going to use some blue. First, I want to find this area. So this area would be what? This area would be half BH, and then well, let's write them down. I don't want to do this. I want to do entire thing at the same time. So this one. So let's divide and conquer. Let's see how many regions I have. This is another region, the blue region, the red region, and then this is probably another region. Okay, and this is probably another region. Okay, so how many regions I have now is easier, right? 1, 2, 3, 4. So I'm going to use a different color to do it. Okay, so now here this is a triangle. So I'm gonna use half BH, and this is a rectangle. So I'm gonna use BH. This is again a triangle. So I'm gonna use half BH, and this is a triangle. So I'm gonna use, of course, half BH. All right, so this is half BH. So half, what is our base? Base is 2, and what is our H is 1. And this is our base is 1, and our H is 1, and this is our base is 5 minus 3. Our base is 2. Our base is 2, and our height is 1, and finally this is our base is, of course, 6 minus 5, 1, and our height is, of course, -1. So now let's add them up. Don't forget, this is our total displacement. This is our total displacement. So let's add 1 plus 1 times 1 is 1 plus 2 times 1 is 2. Let me see, base is for this one 5, yeah, 2. Hold on, so what mistake I made? 1 times 1 is 1, 2. Oh, there is a mistake been made. Okay, so the mistake is half BH, half B is 5 minus 3 is 2, and H is of course 1. All right, so 2. So this is 1. All right, and then finally I have minus half. Okay, so what's going on over here? 3 minus half. So D is 3 minus half. So displacement is 2.5, of course, meter. Right. So this is our displacement, problem number 3. Now problem number 4 also have something to do with this. So I'm gonna draw a DT graph. That's what I asked you to do for problem 3. So to draw a DT graph, let's see what I am doing. Okay, so it's pretty simple to draw a DT graph on this one, if you understand what's going on, right? So there is an acceleration from here to here, right? And there is no acceleration from here to here, and there is a deceleration from here to here. So I have A, B, and C, and maybe you want to call it D if you like. So there is actually nothing much going on there. You can divide it in 4 sections. So the object is speeding up. So let's write it speeding up. Speeding up. Okay, velocity is constant. Object is slowing down. Object is speeding up. Okay, in the future, if I ask you to describe the motion, you should be able to describe the motion, because kinematics is describing the motion, right? You are not inventing or explaining anything, you're just describing. I give you something, you're describing it. Okay, so without further thinking or without loss of thinking, you just close your eye and you make a DT graph that has 4 sections, tells us 4 story. Story number 1, story 2, story 3, story 4. They are different. So okay, so what's going on over here? Let's see. This is region A. Okay, why? Because if you do VT graph, look, if you do VT graph, this region is parabolic. So you have to do a diagonal line. You learn that on day 1, not like day 20. Day 1 we learn it. So this is section A. This is a diagonal line. Diagonal line, you have what? A horizontal line. So this is B, right? And this is slowing down. Why object slowing down? The slowing down is because the object is getting to 0. Velocity is going down to 0. You throw something up and object velocities go to 0. Object is stop, right? So object is stop right here. In order to stop right here, object has to slow down. So object is slowing down. So slowing down to where? Slowing down to 0. Hey, that's it. See. Now object is speeding up again. Object is speeding up again. All right. Just like you throw something up, and after when it is falling again, then it is speeding up. So speeding up means, hey, that's it. And that's how you're going to explain it. A, B, C, and D. There is nothing much. You stop here. Some of you are every person is moving like this, and that's wrong. That's absolutely wrong. Okay, so this is your okay, one more problem probably I gave you, that number 5. Number 5, I ask you at what 2 section object is speeding up. So speeding up, I already answered that question. I see A is speeding up, I wrote that, and I see D is speeding up, D. So that's where you speeding up. A is from 1 to 2 seconds, you speeding up, and D is 5 to 6 seconds, you speeding up. 5 to 6 seconds, you speeding up. Okay, all right, now we're going to do the last problem, and last problem has to do with the relative velocity. Relative velocity, we spent 3 to 4 days on relative velocity. Relative velocity is very important. I just got this problem from Reasons Physics, June 2012. You can go check it. Reasons Physics, June 2012. Exactly, that's where I got it from. So here's what I got. There is a river, right? A river is a river has a velocity, and I gave you the velocity 2 meters per second, right? And you want to go to the north side, the north shore. From south shore to north shore, there is a 75 meter, and the boat is boat velocity is 3 meters per second, right? Okay, so I ask you to do very simple thing. I said that this 3 meters per second, I gave you a vector which is 6 centimeter, right? 6 centimeter. Let me use the ruler to make it 6 centimeter. 6 centimeter. 6 centimeter. This is centimeter, right? So 6 centimeter is too small. You're probably not going to see it. So I'm going to have to scale it up. So 6 centimeter. 6 centimeter is I have to use the rate. 6 centimeter. 6 centimeter, right? Okay, 6 centimeter is 3 meters per second. And then I gave you this one 4 centimeter. 75 should be somewhere else, so I write 75 here. 4 centimeter. I gave you 4 centimeter. So oh my god, this is too small. Is this really 6 centimeter? It's longer than 6 centimeter. No. 6 centimeter is, this is centimeter, right? Yeah, 6 centimeter is right here, so it's too tiny. You're not gonna see. And 4 centimeter is this one. 4 centimeter is this one. All right. Okay, so this is 4 centimeter, right? I'm gonna scaling it up so that you see it. So what are you gonna do? I gave you this 1 centimeter is equal to 0.5 meter per second, right? So I'm gonna multiply both sides by 10, so that later I'll divide both sides by 10. Okay, so 10 centimeter is equal to 5 meter per second. Hopefully you understand this kind of math. If you don't, then see me. Okay, so I'm gonna erase this one because I need this space. So let's see. I want to do, instead of 6 centimeter, I want to do 60 centimeter. 60 centimeter. So 60 centimeter. 60 centimeter. 60 centimeter. So this is 60 centimeter, right? This is 60 centimeter. This is 40 centimeter, right? This is 40 centimeter. Make sure you know how to draw parallelogram. If you don't know how to draw parallelogram, see me in the class before it's too late. And make sure they have arrow. If they don't have arrow, there would be a big problem. So keep constructing the parallelogram. This one has to be same in magnitude, so 40 again, and same in direction, 40 again. And this one has to be same in magnitude and same in direction, 60 again. Make sure you know how to draw this thing, how to do this type of thing. Okay, now we're going to draw the resultant. So I'm going to draw the resultant from this side to this side. I always draw the resultant by red. I missed that. Be careful. Do not compromise with your quality. Do not compromise with your quality. Do not compromise with your quality. All right, I want to find the size of the resultant. So this is my resultant. I want to know the size. 72 centimeter. All right, so resultant is 72 centimeter, and I want to divide by 10 because earlier I multiplied by 10. Okay, so 7.2 centimeter, right? So 7.2 centimeter is how much velocity? Okay, so let's see. This one is 3 meter per second, and this one is 2 meter per second. So the resultant should be this. Come on. The resultant should be this, and this should be what? 3 square plus 2 square, and that should be 9 plus 4, 13 square. 9 plus 4, 13, and this should be about 3.6 meter. So there, let's say 7.2 centimeter is exactly 3.2 meter times centimeter on the top, meter per second on the bottom. So 1 centimeter is 0.5 meter per second. Centimeter cancel, is equal to 3.6 meter per second. All right, so your answer is 4 centimeter, okay, and 7.2 centimeter, right? And you also need to find the time it takes for the board to get from here to here, and that is easy. So D is equal to VIT plus half AT square, right? And there is no acceleration. How do you know? See the size of the arrow. No, it's constant velocity. So D is equal to VT. So T must be D over V, and D is 75 meter, and V is 3 meter per second, and that is 25 second. So it takes 25 seconds for you to go from here to the other side, and that is 5A. Now I'm going to go over 5B.